Ever get frustrated with like those old school flat maps? You know, the ones that rip when you try to refold them, or even those spinning globes, the ones that always seem to get stuck on your finger.
Definitely. They're relics of a bygone era, it's true.
Right. Yeah, well, get ready to like toss those out. Because today we're diving into the world of Earthcloned,
Ooh.
which is a project so ambitious, it aims to make those old maps and globes completely obsolete.
Oh.
We're talking about exploring a fully realized, ridiculously detailed 3D model of Earth
Yeah.
right in your web browser.
And we're lucky enough, like, to actually have our hands on a technical document from them.
Yes.
And it reads like a blueprint for revolutionizing how we visualize our planet.
It's true. This document is packed with fascinating insights, and I think the first thing that really jumped out to us was the problems that Earthcloned is trying to solve are things that, maybe you've even experienced yourself.
Exactly. Take scalability, for example.
Okay.
Imagine trying to load a 3D model of the entire Earth onto your computer. Not just a basic globe, but one with every mountain, building, tree, and stunning detail. Current systems would basically choke.
Oh yeah, my computer throws a fit when I have too many tabs open. There's no way it's handling a high-def Earth.
Exactly. And it's not just about cramming all that data in. It's about, making it look good, too. That's where fidelity comes in. Think about it. A lot of the tools that we use now just lack the detail needed for really critical decision-making.
So, like, if you're an urban planner trying to figure out where a new park should go, you need more than just a blurry satellite image.
Precisely. You need to see how sunlight will hit the park benches, how the new trees will affect sightlines for surrounding buildings.
And most importantly, how the food truck lines will flow.
Of course, naturally.
Okay, maybe that's not top priority, but you get the idea. Detail matters.
Absolutely. The final problem they highlight is accessibility. A lot of the really powerful geospatial tools out there are locked behind, like expensive software or require a supercomputer to run. Earthclone wants to change that.
So, faced with these, kind of limitations, the team behind Earthcloned had a bold idea. What if they built a platform that could handle massive amounts of data, render it in stunning detail, and make it accessible to anyone with an internet connection?
And they didn't just set out to replicate what's already out there, right? They wanted to create something truly groundbreaking. That's where their 3 core solutions come in.
Right. And the first one, I have to say, really blew my mind. They're building this, like, Wikipedia of 3D Earth data. Instead of hoarding information, they're pulling from publicly available sources like, Bing Maps, Google Maps, and even OpenStreetMap.
It's a massive collaborative effort, essentially, leveraging the power of crowdsourced data to build a comprehensive and constantly evolving model of our planet.
Okay, that's cool and all, but what about making it look amazing?
Yeah.
I mean, I'm not trying to explore a pixelated blob here.
Right. Don't worry, they've got you covered. To power those visuals and create a smooth, interactive experience, they're using Unreal Engine 5.2.
Wait, isn't that what they use for those crazy realistic video games?
The very same. This means instead of those clunky 3D models we're used to, you'll be experiencing Earth with the same visual fidelity you see in a cutting-edge video games.
So I can fly through the Grand Canyon and practically feel the wind in my hair. Sign me up. But seriously, all of this sounds amazing, but I need to know, do I have to download some complicated software, or am I going to need an IT degree to use this thing?
That's the best part. They designed Earthclone to run right in your web browser. No fancy software, no massive downloads, just pure geospatial goodness accessible from almost any device.
Wow. So I could be, like, showing my friend a 3D model of their next vacation spot complete with live weather updates, all from my phone.
Exactly. It's about putting the power of this technology into the hands of everyone.
Okay, my mind is officially blown. We've covered the problems they're tackling and their big picture solutions, but how are they actually making this work on a technical level?
Let's dive into that. One of the kind of key elements is their high-fidelity 3D Earth model. Now, that might sound a little jargony,
Just a tad.
but it basically means they're blending together high-resolution satellite imagery, detailed terrain data, and even 3D models of buildings. And we're not talking about giant gray blocks pretending to be a city.
Please tell me they have my favorite coffee shop perfectly rendered in 3D.
You got it. They're aiming for a level of detail where you could practically pick out your car in the parking lot.
Okay, I'm officially impressed. But what about making this virtual Earth feel truly alive?
Right.
That's where I imagine things get really interesting.
You're right on the money. This next part is where Earthclone goes from, like, really cool to mind-blowingly awesome. They've created something called a dynamic data layer, which is essentially a plug-in system for live information.
Okay, so it's not just a static snapshot of Earth. It's constantly updating. Give me some examples.
Imagine tracking hurricanes in real time as they move across the ocean, or watching volcanic eruptions unfold before your eyes.
This is way cooler than watching a lava lamp.
Right. They can even tap into something called ADS-B data, which is like a live GPS tracker for aircraft.
Whoa, so I could actually see planes moving across the globe in real time.
You got it. And it doesn't stop there. Think traffic patterns, weather models, even the spread of wildfires. The possibilities are massive.
All of this sounds incredibly complex.
Mm-hmm.
How do they even begin to wrangle all that data and make it run smoothly in a web browser?
Well, they're achieving this, like, technological magic using a few key ingredients. One of those is WebGL, which essentially allows your web browser to handle complex 3D graphics. But on top of that, they're masters of data optimization, which means they're making everything run incredibly efficiently.
So even with a shaky internet connection, I could still explore this detailed 3D Earth without wanting to throw my phone out the window. That's a win in my book. But who are they building all of this for?
It's a good question, and their document goes into detail about their target audiences. One of the biggest is defense and intelligence agencies.
So move over grainy satellite images, there's a new sheriff in town.
Exactly. Imagine planning a mission on a live, hyper-realistic virtual Earth. You could scout terrain, analyze potential threats, and even simulate different scenarios, all with incredible precision.
That's a game changer. But I bet the applications go far beyond just defense and intelligence, right?
Absolutely. Urban planning is another area ripe for disruption. Imagine designing a new neighborhood and being able to see how it impacts the city skyline before a single brick is laid.
It's like SimCity, but in the real world,
Yeah,
and hopefully with fewer accidental Godzilla attacks.
let's aim for that. But on a more serious note, think about the implications for disaster response.
You mean being able to see the impact of natural disasters as they happen?
Exactly. Imagine coordinating relief efforts with a real-time 3D model of a hurricane's impact zone, complete with data on infrastructure damage, flooding, and evacuation routes.
Wow, that could be the difference between life or death for some people.
Absolutely. It's about making smarter, faster decisions when it matters most. And it's not just about these large-scale, high-stakes applications. Think about the potential for research and education. Earthclone could completely change how we study climate change, track animal migration patterns, and even just teach kids about the world around them.
It's like giving everyone a magic lens to see Earth in a whole new way. It's incredibly exciting, but also a little daunting when you start thinking about the implications of having so much information at our fingertips.
You've hit the nail on the head. As amazing as all of this sounds, it does raise some big questions about data privacy, responsible use, and the potential for misuse.
Definitely something to ponder. But before we get too lost in the ethical weeds, let's unpack what this Phase 1 label on their document really means. What's on the roadmap for the future of Earthcloned?
You're right to be thinking about the future because Phase 1 is just, it's just the tip of the iceberg.
Okay, so they're planning to make this already mind-blowing platform even more mind-blowing. Like what's next on their agenda?
Well, in Phase 2, they're talking about taking data integration to a whole new level.
Okay, and that means?
Right now, they're pulling in data from satellites, aerial imagery, maps, the usual suspects.
Right, the foundation of any good, virtual Earth experience.
Exactly. But imagine layering on real-time data from, oceanic currents, social media feeds, even those sensor networks tracking, air quality or seismic activity.
Whoa. So it wouldn't just be a visual representation of Earth, but also a way to understand the forces that shape it, both natural and human-made.
You've got it. It's like going from reading a textbook about Earth to stepping inside a living, breathing simulation of the planet.
That's one heck of an upgrade. What about the tools to, make sense of all that data?
They're not stopping at just visualization, right? They're building in advanced analytical tools directly within the 3D environment.
So instead of having to, export the data to some other program, you could manipulate it and run simulations right there in Earthcloned.
Precisely. Imagine an epidemiologist tracking the spread of a disease in real time, or a city planner testing out different traffic flow scenarios.
It'd be like having a crystal ball for anyone trying to make sense of complex systems.
And they haven't forgotten about us regular folks who just want to explore and learn.
Because let's be real, I'm probably not going to be running any disease simulations anytime soon.
Well, maybe not today, but who knows what the future holds. The point is, they're making the interface even more intuitive and customizable.
So what, like, I get to design my own dashboards and choose which data layers I want to see?
Think of it like being handed the keys to a spaceship and told to go explore.
Okay, that is an analogy I can get behind. But all this talk about data, tools, and interfaces, how does it all actually work? They mentioned something called cesium ion in the document. What in the geospatial world is that?
So cesium ion is a platform that provides access to a vast library of pre-rendered 3D models and terrain data.
So instead of having to, like, render the entire Earth from scratch, they're using, like, pre-built blocks.
Exactly. It's like having a shortcut to creating those stunning visuals, and it allows them to achieve incredible levels of detail without sacrificing performance.
Very clever. But Earthcloned can't just be a closed system, right? What about making it work with other tools and platforms?
You're thinking like a true tech enthusiast. You're right. They're building a robust API system.
Hold on, pause for a sec. And in non-techie terms, what does API even mean? It sounds like some kind of futuristic beverage.
Think of an API as a universal translator for software. It allows different programs to talk to each other and share information seamlessly.
Okay, so in the case of Earthclones, this means?
It means other developers can integrate their own data, tools, and applications directly with Earthcloned.
So it's not just a standalone platform, but a building block for a whole ecosystem of geospatial applications.
Exactly. Imagine using Earthcloned to visualize data from your smart city sensors, track the progress of a construction project in real time, or even create immersive virtual tours for, real estate.
It's like the ultimate sandbox for anyone working with location data.
And speaking of sandboxes, let's talk about how they're making this virtual Earth look so darn realistic.
Okay, because I've been wondering about that. They keep mentioning global illumination and ray tracing. Is this where my computer science degree would come in handy?
Don't worry, I'll spare you the technical jargon. Essentially, they're using advanced algorithms to simulate how light interacts with the virtual environment.
Okay, that makes sense. But why is that so important?
Think about the difference between seeing a flat photograph of a landscape versus actually standing there in person. With global illumination and ray tracing, they're able to recreate those subtle variations in light and shadow that make the virtual world feel incredibly realistic.
So it's the difference between a flat, lifeless image and a scene that feels truly immersive.
Precisely. And they're not stopping there. They're also incorporating dynamic environmental effects like realistic atmospheric scattering, cloud formations, and even, day-night cycles.
So like you could practically feel the sun on your skin as you virtually hike through the Amazon.
You might still need some sunscreen for that, but you get the idea. It's about creating an experience that's as close to the real thing as possible.
All of this sounds like incredibly expensive. How do they plan on keeping the lights on, let alone funding these ambitious future phases?
That's a great question. No one's expecting you to shell out a monthly fee just to look at a map. Instead, they're taking a multifaceted approach.
Hit me with it.
First, they'll likely offer Earthcloned as a platform with different tiers of access for various users. Government agencies and research institutions might pay for premium features and support.
Makes sense. Charge the big players who need the fancy features.
Exactly. They also mentioned strategic partnerships with companies already working in the geospatial or simulation industries. Think about collaborations with architecture firms, urban planning departments, or even video game studios.
So they're building an ecosystem, not just a product.
Precisely. And of course, a project this ambitious might also attract government grants or funding from organizations invested in scientific advancement.
It's like a moonshot for geospatial data.
Yeah.
But even with a solid plan and funding, it all seems incredibly ambitious.
Yeah.
Do they have the team to pull it off?
Well, building a virtual Earth from scratch takes more than just ambition, right? You need some serious brain power behind it.
Absolutely. And it seems like they've assembled a dream team of experts.
Okay, spill the tea. Who are these masterminds? Well, the document names Ali Mavan as the CEO and principal investigator, which basically means he's He's the captain steering this ship. He's got a background in software development, API design, data analytics, all like essential for a project of this magnitude.
So the technical chops are definitely there. But like leading a project this big takes more than just technical skills, right? What about his vision for Earthcloned?
He's been described as someone who sees Earthclone not just as a tool, but as like a catalyst for change. He wants to make geospatial data accessible to everyone, from scientists and policymakers to teachers, students, and even just everyday folks like you and me.
Okay, I'm getting chills. It's like giving everyone a superpower to see and understand our planet in a whole new way.
Exactly. And he's brought in some heavy hitters as consultants, people who've tackled things like hyper-realistic 3D modeling, physics simulations in virtual environments, and making sure everything runs smoothly even when like thousands of users are exploring the Earth simultaneously.
So they're thinking ahead to when we're all like hanging out in virtual cafes, sipping digital cappuccinos while overlooking the Swiss Alps.
Hey, a futurist can dream. But it makes sense. They're not just building a platform, they're building a virtual world with endless possibilities.
This all sounds incredibly exciting, but let's be real for a second. This is a massive undertaking with a lot of moving parts. Are there any concerns about whether they can actually pull it off?
It's true that projects of the scale always come with a degree of uncertainty. However, based on their track record and the expertise they've assembled, it seems like they're well equipped to handle the technical challenges. Plus, they're not afraid to collaborate, right? They're working closely with experts from Cesium, the platform providing those high-res 3D models we talked about.
So they're not trying to reinvent the wheel. They're partnering with like the best in the business.
Exactly. And by leveraging existing technologies and expertise, they're increasing their chances of success.
Okay, I'm feeling optimistic, but let's wrap things up by bringing it back to like the big picture. What does Terasynth envision as the ultimate impact of Earthcloned? What's their big, hairy, audacious goal?
They talk about revolutionizing how we understand and interact with our planet, really. It's about making geospatial data a tool for positive change, whether that's through, scientific discovery, informed policy decisions, or even just fostering a deeper appreciation for the planet we call home.
It's like they're handing us this incredible gift of virtual Earth that we can explore, analyze, and learn from.
And like any powerful tool, it's up to us to use it wisely and responsibly.
Couldn't agree more. Well, folks, there you have it, a deep dive into the world of Earthcloned, from tackling the limitations of current geospatial tools to building a dynamic, hyper-realistic virtual Earth. Terasynth is on a mission to change the way we see and interact with our planet.
It's a future that's brimming with potential, and I, for one, am incredibly excited to see where this journey takes us.
Me too. And who knows, maybe one day we'll be bumping into each other in those virtual Swiss Alps.
I'll bring the digital espresso.
You've got a deal. This has been an incredible deep dive, and I know I'm going to be checking in on Earthclone's progress with like bated breath. To all our listeners, keep exploring, keep asking questions, and let's build a future where understanding our planet is just a click away.